recording should be any second now.
It is.
It's live. We love it to be live and alive at our age. Hello, everybody. It's the weekly vlog podcast for the South Coast Longtime Telescope and Astrophysics Club, Santa Barbara's astronomical unit. That's SBAU. We call this the SBAU Astro Hour. I'm your host, Vice President Ron Herron. Proud to introduce you to the SBAU Brain Trust Moments from Now. Very knowledgeable group of guys who just love sharing the Zoom screen with me, and we have done for over 2 years. We're in our third year of doing the Astro Hour, Monday mornings, 11 to noon, all viewable on YouTube. All the past programs, 106 of them, this is number 107, believe it or not, are viewable. Start with our website, sbau.org. And we're going to talk this week about the old moon waning down. It's actually a raining moon lately, but we're waning, waxed, however you want to train your telescopes on it, everybody. We're going to focus on the Triesnecker crater, an area that does have its faults. And we find a maser out in space called GO59, springtime galaxies up in Virgo. There's a lot of Messiers up there. And a menagerie of machines on the surface of Mars. We'll go to one of them if we get time. And get this, our local LCO network of observatories around the Earth helped NASA in their crashing a probe onto an asteroid. And now there's another asteroid trying to crash into us. It's kind of called karma. We'll talk about that. President Jerry, how are you? Good morning.
Good morning.
I'd love to talk about the freeway, but we've got to talk about astronomical things. You'll never drive down there again, will you?
Not for a while.
My God. Jerry has been president of our club, a very wise, knowledgeable man for 5 or 6 years now. And we just had our meeting and it was an awesome talk from Stavros, I guess. Yeah. Now, here is our part-time secretary and longtime outreach coordinator, Chuck McPartland, in front of the Ukrainian flag. And over there in the corner is, at least on my screen, is a longtime member and married to Bonnie Bruce Murdoch, active member. Bruce, how's the Santa Barbara Theater Organ Society doing? You're president of.
Well, we're actually, excuse me, having public health outreaches again. We have an open console. We had one last Saturday.
And yours, unlike our Saturday night star parties on the second Saturday of the month, are not called off, are they? We got scrubbed out again.
We have to work around the theater schedule. You know, our standing reservation, and because we don't get charged for the use of the theater to have an open console, is typically the second Saturday of the month. But if they have somebody who wants to pay to use the theater, then we get bumped. We either go a week earlier or a week later.
I gotcha. Well, we had Tom Whittemore, our illustrious ex-Westmont science instructor, on the screen for a moment until his mute did him in. And so just real quickly, before we get to the silly cartoons that Jerry forwards to us, anything outreachable we can talk about, Chuck?
Not really. I mean, Friday is supposed to be the Westmont Public Telescope night, but we'll have to see how the clouds treat us.
Okay. Well, I wonder if it was one of your cartoons, Jerry, no, it was something I saw on nextdoor.com that said, I want to thank you guys for praying for rain. Now stop.
So, no, that's not one of my cartoons.
No, but I thought about that. It kept getting comments saying, yeah, we've had enough. Thank you. Back to the drought. However, on a regular basis, we get forwarded some silly cartoons. Most of them are scientifically based from Jerry Wilson, and I don't know how he finds them, but we enjoy them. And there's the two little green men from Mars or whatever inside the spaceship. Take me away from here, yells the kid. One of the aliens says, I miss the days when they used to be afraid of us. That's true. We're in a new element. And a couple of other aliens talking about daylight saving time on their planet. One of them says to the other, but our planet's rotation is 27 minutes. If we set our clocks ahead an hour, it'll be the day after tomorrow. How do we deal with that? Man, oh man. Okay, here's a couple of them. Can you enlarge that just a bit, Mr. President? There we go. All aliens. I thought it was going to be cats. There's a lot of cats in some of these. Here's the two aliens talking in space. So what happened when you said, take me to your leader? And the other one says, they laughed at me. Could have happened a few years ago.
Could have, yeah.
Here's the two pickle monster aliens going now. Don't forget, Gorok. This time, punch some holes, not folks in the lid. I got humans inside a jar, and you got to punch holes in it, or obviously. Okay, here's the first cat one. They're inside the space station, and the guy brings in the cat in his own spacesuit. You ask how to boost our social media engagement. Anybody want to comment on that one, Jerry? What is the humor there?
No, everybody seems to watch cats on Facebook.
Oh, they sure do. I do it on YouTube.
Okay.
Really, I
Same
like
thing.
cats with dogs together. Oh, here's a good one. I sent this to one of our members who's bought 5 telescopes. Oh no, says the wife, he bought another telescope. And unfortunately, Mike Hardwick's wife has passed away, so she wouldn't be saying that. Here we are. In a biblical sense, thou shalt set the time 1 hour ahead, it says in the scriptures, no more, no less. 1 hour ahead shalt the clock be set, and the setting of the clock shall be 1 hour ahead.
Now this is not the Bible. This is Monty Python.
Oh, is that from the
I think it's the Holy Grail one.
Holy Grail movie? Oh my God. Is that a direct quote from the movie?
Yes.
It's in quotes, yeah.
So we've had daylight saving time how long? 50 years at least, I guess.
Oh,
I
it
don't
dates
know.
back to World War I.
Does it really? And it's about to end. Everybody hates it, including the farmers. And I believe it was here's a bunch of people in space. There's always that guy, nerdy, he's wearing shorts.
Wearing short tennis shoes. Yeah. A little fanciful.
Yeah, that's true. He just didn't have the skateboard.
All
Here's
right.
what
Yeah, we
daylight-
are.
that's what
Daylight-
daylight saving time looks like on our clocks. You're right.
Taken care of.
That's true. I wish I had a clock like that. I had a couple other ancient, these aren't aliens, these are classic dinosaurs seeing the thing come in. Uh-oh, this can't be good. And in the meantime, they're toying with their blocks and making Stonehenge, 65 million years old, tons of blocks. Stonehenge, the real story.
Hey.
And here we go with the kid again. There's you go. So what are we going to talk about, gentlemen? We're going to visit Virgo. We're going to look at the moon, I guess, first, our nearby neighbor, which is waning down as we get ready for more wane tonight.
Well, let me show you an interesting photo that I saw just recently last night.
Yeah, you just added this one, didn't you?
Yeah, I did, but there's nothing to talk about. It's just a very interesting picture. This is the moon Hyperion around Saturn. And it's a very strange moon. It's obviously been hit a lot. And I was just thinking maybe it's a solid core thing and all the dust got blown away or something, but some of these slopes look like they are dust. So it's very puzzling.
Well, it looks like it's
I
very
think-
filamentary or fragile with all of the vertical walls there and the holes in it.
Yeah.
This is a picture from the Cassini
Cassini.
spacecraft.
Yeah.
It took a close up of this moon on the way into Saturn, and they were looking at these holes, and they're similar to the holes you see in snow when soot particles land on the snow and the sun shines on it. The soot particle heats up more than the snow around it, and it melts a hole down into the snow.
Oh, yeah, that's right.
And so they were a bunch of the moons, like Phoebe, and especially the two-sided one around Saturn, Iapetus. They have these polycyclic aromatic hydrocarbons that are dark that they've seemed to have run into a cloud of it. Like on Iapetus, it's only one side of the moon that has it.
Mhm.
And so they think that that's what was deposited on this thing, and then the differential heating from the sun caused these pits to form.
Yeah. Those structures were called sun cups in my basic mountaineering training
Okay.
class with the Sierra Club.
So you're saying this is not a captured asteroid?
I don't know that, but it's a moon now.
Yeah, it's a captured icy body.
Okay, well, because of its shape, it can't be that large or be round or
Yeah.
circle. So it's
I don't know offhand the size of it.
as long as it doesn't hit here, I'm fine with it. And it was discovered by Cassini, right?
No, by the Cassini spacecraft was photographed.
Yeah, we didn't know it existed.
Yes, we knew about it. That's why they targeted it.
Mhm.
Like a big piece of sponge in my kitchen.
Yeah.
It's a very
Okay.
unusual shape. Up here, it looks more reasonable. Well, I don't know. I guess it's just your angle.
Yeah.
Okay. So anyway, the moon,
Go to our moon.
this is our moon. This is not a photograph. This is from a application that sets the moon phase and labels anything you want.
Ooh, and they misspelled Rupus recta.
Really?
Yeah.
Well, that was me. I wrote that on there.
Oh, okay. Never mind.
Rupus recta? It sounds like
You know, a
term.
colleague of mine once said that every time I wrote a document, I proved that I was a scientist because my spelling wasn't worth shit.
Well, now that's several nights ago we're looking at, right? It's
Yeah.
Close
No,
to
this is tonight. This is tonight, March 13 at 12:58 p.m. So I guess that's in about another hour, 2 hours.
okay. So we got this week, it'll still be waning. The next
Yes.
week. We
Yeah,
got
the Terminator is moving this way,
Right.
darkening more of the moon. The reason this is here is because this sets the stage for where several features we're about to talk about are. And one of them is Rupus recta, anyway, called the straight wall, which is right there. These are features that you can see on this at tonight, if you were interested. And then my favorite set of three craters, Ptolemaeus, Alphonsus, and Archangel or
Arzakel,
Arzakel, thank you. And then
an upside down snowman.
yes, it is. And then the crater Trisnecker here. How'd I do in spelling there?
Well.
We'll see.
Second.
And then there's a lot of rills and faults there that we're going to look at from some really nice photographs.
We're going to zero in now, right?
And Tim Crawford sent an email or something about talking about the Lunar X in a few days. But
Lunar X.
that's going to be when it's a full last quarter.
Well, that's
Straight
just after first quarter.
Right.
So that's
first
coming
quarter.
up in a couple of weeks.
Okay, good. So anyway, this is, I guess, last quarter is tomorrow, I think, if I remember right. This is one that I inserted. It's the new thing in this adapted thing. This spot here is a momentary flash. The video is available online. And
Space.com.
yeah, and you'll notice I couldn't find in Photoshop how to flip this around. You notice this is a mirror image. Everything's backwards. I don't know if they were trying to simulate the appearance of the moon in a telescope or why they flipped it. But this is the APOD from, I think, yesterday. And the video is very nice that shows the moon in this flash again. So as soon as this part gets lit, well, the event wasn't yesterday, but they're posting it was yesterday. This event happened on
February 23rd.
Yeah, thanks. I'm losing my dyslexia. I can't read backwards.
This is supposed to be a video we're watching?
No, this is not a video. This is just a still frame from the video.
There's a video on space.com.
Yeah, and that's where I got the
Okay.
reference to APOD from. This is obviously taken when the moon was a crescent earlier in a few weeks ago, and or a week ago, 2 weeks ago. And so once this is fully lit, we can look down there and see if there's a new crater. Now that's it's a lot of energy release, so it's a big flash, but the crater is going to be small enough that you can't see it by telescope from the Earth. So one of the orbiters on the moon, and I forget the name of those, they're going to go over it and photograph the area in a routine manner so that we'll be able to see if there's a new crater there.
You suppose that's a good sized asteroid or rock that would have done damage here if it had hit us? Or
That's probably softball size, Ron.
Oh, so our atmosphere would have burned it up.
Yeah.
And the moon doesn't have an atmosphere, so it
Mhm.
makes it.
Well, the flash on space.com when it hits lasts only about a second.
Yeah, it's very brief, but bright.
Oh, yeah. It's as bright as the sunlit side of the moon.
Mhm.
Well,
So a lot of kinetic energy. It probably hit typically things like that are doing about 30,000 miles an hour, which is a lot of kinetic energy. If you do the 1/2 mv squared, it's velocity squared. So that's a big number of ergs. This is the region around Tri-Snecker crater. This shows the rills here. This is in French. This was posted on Facebook from Robert Keselak, a French amateur who does excellent photography.
for the benefit of our viewers that might not know, including, I guess, myself, what's a rill?
These lines are rills.
Are they cracks like faults?
That's
They're like rocks rolling in sand.
They can't be water troughs.
Some of them are cracks, but a lot of them are where lava flowed and kind of melted the surrounding rock, and then it collapsed, or a tube that collapsed.
mhm.
Okay.
So, and that I think is a collapsed tube is these bigger rills up here because there are bridges over it and sections out of it where the collapse was more dramatic.
Oh yeah.
This was taken with a C14, a Celestron 14 Edge at f/22.
Huh.
He lists the camera here, but ASI 1600, but I don't know the camera type from that.
I think the C means it's a color camera.
Okay.
So this is real color we're looking at here. Gray.
Well,
Not
he's got a
terribly
filter
close.
on it.
Oh,
Yeah.
are we inside a big mare?
It's Mare terrain around it. Yeah.
Okay.
That is right here. This crater is Tri-Snecker, and that's the crater you see in that picture. So it's in a little flat spot, like a bay of a mare. It's near the Sea of Vapors.
Sea of Vapors.
Yeah, Mare Vaporum.
Well, a little chance of seeing them this week, I assume.
You can go out and see it tonight if you have a scope and set up and the clouds weren't there. Actually, we're having dense fog last night at my house.
Everywhere. Been incredible. And there's another storm. There we go.
Yeah, another storm coming on Tuesday, I hear.
Wow.
Tomorrow. This is Rupus
Recta.
Thank you. My
Rupus
brain is immune to Latin. So anyway, it's a fissure, a fault that a vertical split fault. It looks straight. This is from a spacecraft, obviously, very high resolution. This is from an amateur telescope here on Earth, and this is what most amateurs see. They look through it. This is from a.
It's like video.
I think it's with a 4.5-inch telescope
Okay.
and with an Olympus digital camera. I put that on there because I know Tom uses an Olympus camera a lot. So these identified the major features around it, but it looks like a straight line, and it's called the straight wall. But as you can see from here, it's not exactly straight. It's just at low resolution. We can't tell. And it looks like a cliff. And for a long time, I always thought it was a vertical escarpment, but it turns out it's a slope of about 70 degrees. But when the sun is right on it, it shades all of the escarpment, so it looks like a straight line. This is a high resolution view. What is this one from? It doesn't attribute whether it's a spacecraft, but this is consistent with what you get from an Earth-based telescope, a large professional Earth-based telescope. Now these little, yeah, go ahead.
That's not a rill, though.
It's not a what?
A
No,
rill.
it's not a rill. It's a cliff
Okay.
or a steep slope.
This is sticking up, whereas a rill kind of sticks down.
Yeah, this is a rill here,
Yeah.
and this
Okay.
rill starts at this crater. So there might have been fluid lava under there that punched a hole, and then lava flowed down there and made a tube and collapsed.
Wow.
Now these features down here, these little flakes and stuff that are part of the surface but raised up, these are classic pressure ridges. You see this kind of stuff on ice floes on top of in the North Pole where the ice is floating on water. It's when the ice is being compressed or forced into each other, plates collide, and it gets relief by pushing up parts of itself at the interface.
It makes a lot of noise when it does that too.
Yes, it does. And so that was probably occurred when the lava was hardening. And I would assume that the lava is harder, maybe it occupies a bigger space, but I don't know that, so don't quote me. Or it could just be an earthquake that made it move, or a moonquake that made it move on each other.
This picture and the two pictures before are reversed from one another.
Yes, one is this one is as you'd see in an amateur telescope, and it's been flipped, or not, it's flipped because of the optics involved.
Well, the one before that, the one from the spacecraft, it also is curved.
Yeah.
The opposite
Oh,
way.
yeah.
Yeah.
What a great looking place to land an Artemis crew.
No, if it's nice now and it's flat, maybe, but it's part of the moon that will experience a hot day and a cold night that's 2 weeks long each. And so they don't want to do that. They want to land somewhere at the South Pole where they have access to solar radiation all the time up on a mountaintop. They can put their solar panels up there.
Really? On the South Pole?
Yeah, now they're not staying for a month Artemis 3, when they land. I think they're only going to stay there a few days at most and then leave.
Tim is watching and he's been texting. He really likes to look at the straight wall. And if you go back to that high resolution picture 2 forward, he likes to point out to people that it looks like a sword. You've got the hilt and the handle down there, and then the sword pointing upward.
Oh yeah, I guess one of those fancy Spanish cup things. Yeah.
Oh, my damn.
Little bent, but yeah.
Yeah.
On one of your pictures, the word BIRT, B-I-R-T-A and B, what is that?
Those are
Craters.
the name. Yeah.
Same crater or several craters?
Several craters. The BIRT is the major one, and it's named after some scientist named Bert. And then BIRT B and BIRT A are craters that are near BIRT.
I got you. Okay. And that's in the vicinity.
Yeah.
Yes.
We're looking. Okay. This looks like a great place to land a crew and let them slide down that 70-degree slope.
I'm not sure that would be a good slide. I think it's pretty rough and bouldery.
Oh, you think so?
Anything back up that's tough.
This few anecdotes I remember hearing from the Apollo missions is that, first of all, the moon dust, when it gets in the cabin, it smells like spent gunpowder.
No kidding.
That's what they comment on, which is actually a smell I always liked, but because I did a lot of shooting when I was a teenager.
That's the smell of sulfur dioxide.
I don't know exactly chemical it's due to, but it's a characteristic smell.
And also recently, they're worried about the moon dust because it's got a lot of little tiny nickel iron spherules in it because of the meteorites hitting the moon.
Mm-hmm.
And it's very abrasive. And also it's electrically conductive. And so it can really mess up your equipment. And so they just recently did some tests for Artemis where they dressed Barbie dolls in miniature versions of the suits made out of the same material that they're going to be wearing. They covered them with, moon dust analog that they made. And then they looked at various ways of cleaning it off. And the way to clean it off was apparently some kind of liquid nitrogen blast.
Well, if the stuff smells like gunpowder, what if it were combined with oxygen and sparked or lit? Would it?
Oh, it's gunpowder after it's fired, not gunpowder before it's fired.
Oh, okay, that's good to know.
Yeah, it's completely oxidized.
I'll be damned.
So anyway, and Chuck mentioned the other anecdote that I recall too, and let me add to his comment that the abrasiveness of it had an effect on the ability to seal the lunar module doors or hatches because of the abrasion. People brought into the vehicle on their suits and it got in the door seals. And they figured that by luck, they took off in time before it completely degraded the door seal and it would no longer seal. But it was a real possibility. And so they're working to avoid that. And that's why they're worried about how to clean it off.
Wow.
So anyway, a little Windex, I think.
No, sticky tape. Windex wouldn't work on the moon.
Oh, that's right. Oh, no, why not?
So there's things left behind by colliding asteroids that aren't in the moon's material, its own surface anyway. It's just different. Why
Yeah,
would it be-
nickel iron spherules. Yeah, those are from
Yeah.
impacting things
Right.
like that softball that made the flash in the earlier picture.
Well, why
Other
is
than
it?
that, other than that added material, the moon is basically made out of the Earth's crust.
Yeah,
Well, we got iron and nickel down here. Why doesn't the moon have its own?
it does, but it melted and went to the core. It doesn't have huge amounts. You know, we don't have huge amounts of it on our surface, but it does because of all these meteorites hitting it.
Yeah.
Well, I thought the moon was more granite than it was other things because it was from our crust and not from deep down.
No, granite comes from evolution. It's
It's
It's like a-
igneous, yeah. No, the
Combined-
moon is anorthosite largely, which is
Right.
calcium aluminum inclusions and other silicates.
Do you suppose there's still some molten liquid center of the moon?
We think there's a small one, but we don't think it's very active anymore.
Yeah.
That's ongoing, actually, trying to
Yeah,
figure that out.
we put a seismometer up there and we do get moonquake data.
Yeah.
So anyway, this is the three craters, Ptolemaeus, Alphonsus, and
Arzakel.
Arzakel. Okay. And this is in the region of the Straight Wall.
Well, that's the sword.
Yeah.
You can see the
Yeah,
handle
that's
on
the
the
sword,
side.
but from a different lighting angle, so it doesn't look so much like a sword. I guess it does.
That looks like a hilt of the sword over there.
And here's a crater that's very old and it was completely flowed in by lava. These are obviously much newer craters. This one had a liquid core, or it filled with liquid, and that's where the surface came from. This one has a mount in the center, as does this one. And that mount comes from, my understanding of it is, and correct me if it's different, your view is different, but when the impactor hits a portion of the moon and the impactor act pretty much as a fluid and they rebound, and just as it's starting to come back up and squirt up in the middle, that's when it freezes and you get that one there.
Wow.
So anyway, these are here is a little pattern of very fine things, maybe a row of crap that flew out and hit the dust from here. So
Well,
That
you-
is funny, yeah.
You said the upper left one, the biggest one that doesn't have the middle, it was filled with lava.
yeah,
Did
Yeah,
it
you can
make
see-
its own lava when crashing, or
No,
it didn't?
Lava was more fluid.
yeah.
this
I
would be
believe
stuff that
it-
oozed up afterwards.
right. It broke through something.
Oh, wow, okay.
But this is a neat crater to look at. It's easy to see, and you get about this view in a really good telescope from Earth, amateur scope. But when the sun is at low angle like this, you can see all these little bumps and hills and compression ridges, and these things, shadows go across the rim. It's really got a lot of structure to it. It's really neat to look at.
Albatignius is the same way.
What's that?
Albatignius is the same way.
A similar crater, yeah.
Yeah,
Similar, yeah.
yeah. There's a number of similar ones.
It's got a dimple in the middle too.
Mhm.
Like you could skate on them.
It does at lower angle. You'll see that you couldn't.
You couldn't, it's all right.
Okay. New
Okay.
topic.
New
Now,
topic, where are we going? What is this? Galactic? Are we
This
going up to
is
Virgo? Oh, no, we're gonna
this is-
check out,
this is another guy, Hap Griffin, that is an amateur that I've met at the Advanced Imaging Conference, and he offered to modify some cables as a source of, what do they call that? A side hustle. And so he's modified some of my cables for me. This is his radio telescope that he made, amateur made. It's 1.8 meters across.
His name
And-
is Hap Griffin.
Hap Griffin.
Gotcha. Okay.
And this is a trace that he's done along the meridian of our galaxy as it passes overhead, so 60-degree galactic longitude. And you can see these two peaks here. Now and we showed these before in his instrument, but he's added to that. This is a map. He did not make this map, but this is a radio map of our galaxy. And at 60 degrees latitude right here, you can see the density of hydrogen, because you're looking at neutral hydrogen. I believe it's the 21 centimeter line, but this GO59 is this spot right here, and that shows up as one of his peaks. The red is Doppler shifted, so it's moving away from us, and the cooler colors are blue where it's shifting toward us. So you get a lot of motion of the gas in our galaxy. And he's looking here next to the Sagittarius arm. And I put up here a labeled map of our galaxy. So we are right here. And here's the Sagittarius arm here. I don't think he has this is not from him, this is, but we don't have GO59 marked on here. But it would be in this region here.
And you can only see it with radio telescope.
Well, this is a drawing that mimics the visible appearance of our galaxy. And it's a map from what we've been able to determine about our arm structure. But that particular hydrogen band in the radio part of the spectrum is what you see for radio band, for radio waves.
You called it neutral hydrogen. That just means, well, one proton, one neutron, and one electron.
No, one proton, one electron.
Oh, not even a neutron. And they're free flowing in space, and there's enough there you can see something or get radio waves from it.
That's how you trace the spiral arms, because that's where the hydrogen is concentrated.
Yeah.
But how do you put latitude and longitude on a whirling flat disk? Isn't that just on globes like here?
Same way you put it on a swirling flat or a swirling sphere.
How? I mean,
There's this one here, we're looking down from the North Pole of the galaxy.
Okay, the other side would be the South Pole.
The other side would be the South Pole, and the lines of longitude would spread out from here.
From the middle of that bar.
Right.
Okay, and go around the edges and okay.
It would spread out from this side. It would be a maximum extent at the rim, and then it would continue back and close on the other side.
You can see they've marked the longitude on this image, and the direction toward us, toward the sun, is the 180, and then the direction away in toward the center of the galaxy is the 0. So that would be the far side of the galaxy there,
Yeah.
Okay, we're in the middle.
No, we're down near the bottom there, where
Right where the cursor is. See the cursor here, right there, sun.
Well, I didn't mean the middle of the disk. I meant the middle of the flat side. We're as far from north as south, aren't we? Pretty much.
Well,
we're in the middle of the Orion.
Oh, I see. We're in the plane of the galaxy.
This is longitude, Ron. So this is east and west, really, that we're talking about here.
Okay, are the latitude lines concentric circles?
Yes.
And we're at 60?
No. 60, 180. This is 90 degrees here. And so 60 would be somewhere around here.
Wow, this is all new to me.
Yeah.
Up toward the 10 o'clock position.
It's a long stretch geometrically for you, I guess.
Okay. So what we're talking about with Geo, what is it, 59?
You're clicking, Ron.
Am I clicking?
Yeah.
Hello. That's not good. Geo 59, is that what it's called?
Yes.
And is it technically a nebula?
No, it's a hot spot in the galaxy. And
Hotspot.
he scanned along this line.
But you can think of it as a nebula, Ron, because he's looking at clouds of hydrogen.
Yeah.
Okay, but they usually say gas and dust. And to me, those are two radically different things. Gas is just free electrons. Dust is
Well,
chunks of things, are little, they're little chunks, but they're zillions of
all right,
atoms.
think of it as vapor. You can have vapor from all kinds of things.
Well, my idea of vapor is water.
Yeah, steam.
H2O.
But you can have vapor from all kinds. You can have smoke, essentially is vapor too.
Can you
Well,
see
that's polio versus,
Yeah.
atomic.
that you can see gaseous hydrogen?
In this
No.
radio wave, yes.
Yeah.
But an optical won't. What's blocking it from optical?
Well, it's neutral, so it's not like the ionized hydrogen that fluoresces pink.
It's not emitting in the visible.
Yeah.
If it's
Emitting it.
ionized hydrogen, it emits in the visible.
But it spawn a star.
It could.
No, these are clouds of hydrogen that make up the nebula.
I know, but sometimes they're nurseries, if they collect again, get
Yep.
gravity
Yep.
going.
Yep.
Okay. And your friend does that with that little dish you showed us.
Yeah.
In
And
fact,
we had a guy in the club that does this too. And he used to set up on astronomy day at the museum and show people, especially Jupiter is a particularly bright hotspot. So he'd track that.
wow. Well, I used to have a dish, but it was an antenna back in the 70s,
Same
80s.
thing.
Should have pointed it at the sky.
Yeah, it's true.
The guy that Jerry's referring to is Jerry Polivka, the late Jerry Polivka. But I've got a kit radio telescope that he made that he produced, and I put it together, and it's made from a wok, and it looks like a little antenna like you'd use to get dish TV, and it's got actually a 12 gigahertz commercial TV microwave receptor in there, and you point it toward the sky and scan it along, and there's a little ammeter that the needle jumps when you're seeing more radiation.
Made from a wok.
Yeah.
I would imagine you'd have to cut the bottom part of it. It's a little.
No,
It's
Really?
a reflector.
it's a reflector, and then you have a little tripod sticking out from it that holds the receptor at the focal point.
Really? All right. And we know that the the Milky Way has two major arms and then in between arms, like.
Oh,
what
they
we're-
argue about that. 4 arms, 2 arms.
Okay, this shows two, and we're in between.
Well,
between-
look at there's Sagittarius arm, there's Centaurus arm, there's Perseus arm, there's Norma outer arm, there's a Centaurus arm, Perseus arm, Norma outer arm. So people are still arguing over what are major arms and what aren't.
Yeah.
Can the bar be seen somehow?
In the
Only
what?
with radio.
Oh, in the bar. Can the bar be seen? I thought trying to picture a Barbie doll in here.
Okay. Fascinating stuff, gentlemen.
Mhm. It's only very recently, I think, that we can see this. We determined that there's a bar there.
Yeah,
When I was a kid, we thought we're not a barred spiral.
right. The grand design spiral.
Yeah.
Well, it means there's a lot more stars in that bar than around the bar, and I never have understood how they move. But
Yeah, I wouldn't bet on that. There's more in the core. The outer stuff may look less dense, but it's got a much bigger area.
okay, this is LCO.
This is right here in our own hometown, the
Cumbres Observatory.
Los
Right.
Cumbres Observatory. And they are, as you know, a worldwide net of telescopes, and their unique feature, which is very useful, is that they can observe an object continuously by handing it off from one observatory to the next as the Earth rotates. So they are always in the dark, you might say.
Right. Well, that's part of their logo, isn't it?
Yeah, I think so.
But not all of these are LCO telescopes. This is
No,
a
they're
bunch of
not
other
all. No,
telescopes
that's right.
too.
These are the one. This is the network that looked at and followed. We're helping support the DART mission.
DART, which stood for, what is it?
Dual asteroid redirection test.
That's right. We crashed into an asteroid, and now we're going to talk about an asteroid that's going to try to crash into us maybe in the next 20 years.
Oh, that's coming up in a little bit.
Yeah. Well, right now, this is fascinating.
Yeah.
Just in case,
So,
let me just can I make just one quick announcement?
please.
Our May 4th, First Friday guest will be a young man who works with LCO and its director in Goleta, Sandy Seal. They're both going to be with us for a live report, probably on this. I haven't talked to him. His name is Joseph Farah. Her name is Sandra Seal. And they're going to both join us live at Farrand Hall in May. So
Okay.
two general meetings away.
Now, LCO was started by Wayne Rosing and endowed with his personal money for about 15 years, I think. Now it's running on grants, and it's associated with the University of California at Santa Barbara as part of the physics and astronomy department. And it provides resources for astrophysics PhDs. Great people, great resource.
Yeah, they're a real friendly bunch.
Yes. And they're right here in Goleta with us, at least their home office is. They make their telescopes here and then they ship them off as a kit to positions around the northern and southern hemisphere. So they get complete coverage of the Earth.
Did they finally bring their telescope that's located at Sedgwick into the array?
I don't know if that's one in there or not. I think they donated that to UCSB.
Oh, okay.
For outreach.
Yeah.
You
I
know,
think
you're upside down, Bruce.
I think they can use it, but it's not normally part of the entire network, I don't think.
Well, can I ask a question? Do you suppose if there is no telescope in Antarctica at the bottom of the Earth,
Yes, there are.
there some?
Yeah.
Right there.
I didn't even see that. I was just looking at that spread out Ross ice shelf.
It's about an 18 to 20 inch telescope.
All right, my question was going to be the southern sky. There's just as much sky to the south of us underneath.
Oh,
Well,
yeah.
all
no,
you have to be is south of the equator to see all
here,
that.
this is their old logo, Los Cumbres Observatory Global Telescope. They have a 1 meter telescope in Chile.
Right.
And South Africa and Australia.
Yeah.
So as soon as you're south of the equator, you can see the entire southern sky.
Yeah.
Oh, I see. Okay.
They can see it wherever it's dark at any given time. So whichever telescope is in the dark, they can look through that one.
Is there a southern version of Polaris?
No.
Yes. Well, it's not as bright as Polaris, but it's called Sigma Octantis, and it's not as close to the southern pole. So
And it's not
they're not as
bright.
lucky as we are.
Right.
Are there any constellations down there in the south?
Sure,
sky?
absolutely.
Oh,
Those are all those ones for the industrial age stuff, like the clock and the air pump and the furnace and,
The sextant
telescope. Yeah, the American Indian, flying
And,
fish,
and the Southern Cross.
Southern Cross, peacock.
but now these are all optical telescopes scattered across the world. This has nothing to do with those giant radio receivers that give us the long distance probes that are still in space that are receiving stuff.
Well,
Voyager 1.
Goldstone is listed on here, and that's one of the sites for radio telescopes and the radio receivers.
Right. And Green Bank, West Virginia, that's a radio telescope.
I thought there were only 3 big ones, Australia and okay.
China has a very large one. Puerto Rico's collapsed, and China has the biggest fixed one now. But there's a number of them around. We have several arrays.
Puerto Rico was in a James Bond movie, wasn't it?
Yep.
It was.
100
I
feet.
guess
up.
that weakened it.
Yeah.
Maybe it overgrew with jungle.
It overgrew with rust in the cables that hold it up.
Oh, is
Yeah.
that what it was?
Yeah.
Damn. All right. What are we looking at here, Mr. President?
Okay, so target Earth
Oh God, here we go.
in
There a
It's
name?
going to be sensationalized in the news, I know, but it's probably going to go away and be nothing. But a Tunguska event size asteroid classified as a near-Earth object of the Aten group, approximately 50 meters, that is 160 feet in diameter, was discovered on February 28th of this year. And it has a 1 in 500 chance of hitting the Earth. And it's been designated as a potential danger and given a Torino scale of 1. And this is the Torino scale. So that has been classified here as a 1. So it's a routine discovery in which a pass near Earth is predicted that poses no unusual level of danger. So, but 1 in 500 is more than normal. So current calculations show a collision is extremely unlikely with no cause for public attention or public concern. New telescopic observation will likely lead to the reassignment to level 0, which means meh. But it was discovered less than a month ago, and it was observed for, I think, 4 days. And that gave a
Five colors.
observation arc was 6 days. So
And then it got blocked by the sun or the moon, I think it was.
yeah, so they will pick it up again later, and as they get more data spread farther apart, their orbit will be more accurate. But so this near passage is in 2049, I think. I don't see it on
2046.
there. 2046. Okay, so I will be 102. So lost my train of thought there.
So the orbit will get refined, and you know, it'll either get worse or it'll get better.
Yeah, no, you're right. You picked up my train of thought. Even though we get an accurate orbit that it's in now, that orbit may change as solar pressure causes it to emit gases, or it passes near something and it changes its orbit. So that's why we're going to watch it there.
So there might be a chance we can do what we did with DART. If they decided, you know, it is going to crash, we better.
Yeah, small enough, we might be able to do it. Here's a photograph of it. 2023 DW is its official name right there. And if it does hit the Earth from today's orbit, most likely it'll land somewhere in this arc, which is centered in the middle of the Pacific Ocean. So if you want to get a good show and it does come to the Earth, you want to be in Hawaii at the time.
Get out there with your surfboard and your
yeah, because it will make a tidal wave.
Yeah, big tsunami. Yeah.
How in the world do they come up with that? The damn Earth has been spinning 40,000 times by that.
It's a throwback to deterministic physics. Basically, not Einstein, but Newton developed his law of gravity, and the laws of mechanics is 3 laws. And that's accurate enough that we use it for all our calculations of getting our spaceships up there and getting them in orbit and hitting Mars with it. It's extremely accurate in almost every case that we come into, and it completely determines what's going to happen here. There's no relativistic effects. It's not moving that fast. So
what they've done, Ron, is they took the current measurement for the orbital parameters for this asteroid, but each parameter has a little uncertainty on it. And so they ran a series of simulations with the values dithered among those uncertainties. So they ran thousands of simulations, and these are where the simulations resulted in impacts. And it was only like 1 out of every 500 of their simulations.
Okay, well, I know the Pacific is very big. It's what, at least half the Earth's surface itself?
mm-hmm.
And earlier in the show, you know, we were talking about all those craters on the moon. It might crash into the moon too. Would they be able to tell that?
Yeah.
More accurately later in a few years.
Okay, but the Tunguska, that happened in what, 1908 in Siberia?
Yeah.
And that was rough on a bunch of animals. I don't know if it killed anybody, but it sure wiped out the there's kind of a crater there now. It's overgrown. But
Knocked a lot of trees over, but there's no remnant that I know of. It might have been a giant ice ball that blew up in the atmosphere.
Yeah, current thinking is it was a comet that blew up in the upper atmosphere, and it didn't leave a crater, but it did flatten trees radially outward over a huge radius. And they did find small bits of debris, but nothing comparable to what the size of the impactor would have been if it were solid.
no reports of a giant explosion from anybody in Russia?
Oh, absolutely.
yeah.
They heard it in England even.
Yeah.
Oh,
They
okay.
detected pressure waves in England from that. And there were people who were thrown out of their chairs miles away. And I think there were a lot of reindeer and a couple of reindeer herders that were killed.
Wow.
Mhm.
But it's not a total catastrophe as far as the dinosaurs 65 million years ago. It's not that big, right?
That's
Oh,
right.
no. That was 6 miles. This is 160 feet.
Okay, man, oh, man.
You talked about the emulation of the orbit, and recall that myself, Farshad Barman, and oh come on, mental block. Anyway, gave a presentation at the December meeting of the simulation that I did using a numerical solution of the differential equations, and we were able to simulate the NASA parameters to like 17 places, 17 digits. And I didn't do any relativistic stuff in there either.
Yeah.
Where is this sucker right now? Is it in the asteroid belt?
Ah,
It's out there. I don't know exactly where. We'd have to look at the discovery.
But it's in a strange orbit, or is it in our orbit?
No, it's just in an Earth crossing orbit.
yeah, it goes from half an AU to 1.1 AU. So it's roughly in the Earth's orbit or near it.
Yeah. So that's if anything, it just barely reaches the inner edge of the asteroid belt.
Yeah.
That's
Its orbital
wild.
period is 3/4 of a year.
Okay, and our
It's
president
comparable to Venus.
right.
Yeah.
And our president of the club hopes to be 102 when it happens, so he can see it from his hospital bed.
No, from his deck.
That's true. Yeah, he'll be still healthy.
Yeah, we
Oh,
may
yeah, I
be
can
around
see
with
the-
metal parts by then.
What
Well,
did
you
he-
see also, depending on your feelings about politics, it looks like it could nail Washington, D.C. right there.
Yeah, but nobody important would be killed.
Okay, some Messier objects, or do we have time to go to Mars? And spring.
Mars has got a lot of pretty pictures.
Yeah, that we talked about Mars last week.
Yeah, but this is an add-on to it. We've got a few minutes here, 6 minutes.
All right.
So
on the
this is-
Menagerie.
This is an update to the plan to retrieve it. Now, this is a composite drawing that shows all of the players involved at different times. And this is the rover. And
Perseverance.
what?
Perseverance.
Yeah, this is Perseverance. There's this little nuclear reactor on the back end, doesn't have solar panels. And this is the return vehicle. This is the in-orbit transition gateway, or else it's the
Reconnaissance
Mars
orbiter.
orbiter. And this is the helicopter whose name I've forgotten.
Ingenuity.
Ingenuity, yeah. So they've established now a place called the Three Forks or Three Rivers, Three Forks, and these are ampules that it has deposited in the shade of the tree of the rover. And so this is the site where they're stockpiling them. There'll be other sites too, but this is one where they're going to get them.
Huh.
So they don't want to keep them with the rover forever because the rover might get stuck in a sand dune somewhere that might be hard to get at, and then it would have the ampules on board. So they periodically put these down. This shows the self-portrait of the rover, and there it's got one of them just deposited on the soil. So it looks like it's easy to get to.
I wonder what the separation is between the various deposits.
I don't know. Whoop.
Hundreds of feet?
No, I don't know.
Oh, okay.
But they are
There's-
going to try to
there's-
make it really easily identifiable areas so that they
Yeah.
can then come with a helicopter and pick these up.
So there's tracks back there. There's no tracks there. There's some tracks. And you can see there's some tracks around here. So I would say that there could be other ones in the picture. Maybe one, no, that's a rock around there somewhere. I don't think they're all stacked right next to each other.
Or this was just the first one they deposited here.
Yeah. Yeah.
Was this picture here taken by Ingenuity? We just switched
Yes.
that? Yeah.
No. This was taken by the Perseverance.
Perseverance, excuse me, I mixed ingenuity.
They reach out their arm and they take multiple pictures and then they composite them. That's why there's some distortion
Right.
here.
Yeah.
I don't see the arm coming.
Well, the arm is taking the picture, so they just basically erase that from each shot.
Oh, okay. Okay, there you go. Fascinating.
It has a selfie stick on board.
Yeah.
And
If
so
you zoom in on this, the previous picture, and directly in the about 10 links of that deposit they put down away is another stick. It looks like, it looks very much like the same thing.
Where is you talking here?
You're right.
looks like it's doing
I
a
blew
U-turn.
this up 500 times, 500x.
Huh. Wow.
Yeah, I can see it breaking up already. So making it bigger won't help. I don't think. Let me try it.
So somehow they're going to fly a probe there that'll pick up all 10 of those capsules that are pictured, each with different material in them,
Yes.
dust or rock, or
Mhm.
did it do some drilling?
No, they pick it.
It did drilling to collect these samples.
Right.
That's what I meant. Yeah.
Yeah.
Wasn't there a little drill that went into rocks?
Yep.
Yes.
Yeah, it cored them. Took
Mhm.
the core out of the middle.
And this is a feature, a mound of what's believed to be the clays that they're want to look for in the delta that they think is might have evidence of life in it, past evidence. So
Really?
that the core samples, some of them came from that mound.
Really interesting looking rock kind of in the middle of that delta deposit. That looks like that could be a meteorite with the regmaglyphs in it.
This one,
Yeah.
yeah. Well, they've all got glint on them from the sun angle. So
Yeah,
that
but that's
shows-
got regmaglyphs, the
Yeah.
Well,
The
when I blow it up,
cavities.
it just looks more like a rock. No, it's not really too asteroidy. Never mind.
Okay.
Yeah, a meteor would have gone deep. It wouldn't have just landed and laid there on the
Yeah, but
surface.
there's been erosion here. There's,
Oh, I see. Okay. That was
So
Ayers.
this is the overall return, what's going on.
There you go.
This is the Mars mission that launched Perseverance. And that was in 2020. Perseverance cruises around on the planet and leaves these ampules. Then the sample retrieval lander mission goes up and it lands and it puts down a rover. And this rover goes around and here it is picking up all these, see 3 amples there. It's picked them up, cruises around the same pattern. It goes back here and it goes to a launch facility where then a rocket takes these samples up to the gateway, which looks like that satellite that was in the first picture. And then the samples are loaded onto a return mission. And that is on a lander that comes back to Earth.
Wow.
And I think now this was one of the original proposals, but I think now they're looking at using a helicopter. 'Cause it'd be
Yes.
much faster than the little rover for collecting the samples.
Mhm.
But there's only 1% of the atmosphere that we have, so they have to really spin not 1 but 2 rotors.
Yeah, but they know how to do it now.
Yeah.
Also, they'd send a new one or expect
Yes.
Ingenuity.
No, they're
to-
not.
No. Ingenuity is too small to do this and doesn't have a grappling mechanism.
Oh, gotcha.
You take a
Brilliant.
look at this diagram and you notice all the things, everything has to go right. There's a lot of single point failures that just would squash this whole endeavor.
Mhm.
But that's the same
Another-
with the whole landing thing of Perseverance in the first place too.
Yeah.
Right, but that's just, yeah, but that's only 10% of the number of single point failures that they could in the whole mission that they have here.
Yeah, well,
Yep. It's all risky. Space is risk.
Yeah.
the man that made the two cars two of you gentlemen are driving would love to have people there picking these up, I'm sure.
Uh-huh.
He wants to do though. This is a depot or an office or not a community. What was the word you used?
This is a research station, I would assume.
Okay. Everything is pressurized.
Yeah,
Like-
I would.
It's like the ISS, but on the surface of Mars.
Mhm. Well, you really would enjoy a walk once you got back on Earth.
Yeah.
Yeah,
Well,
I
thought
don't know.
that
You'd
they-
feel like you weigh too much.
Yeah, well, you'd enjoy it, but you'd be in a chase lounge.
I thought they were going to have to put their habitation underground at Mars to get away from the radiation.
there you
They
go.
might.
Good point.
These-
Yeah.
Those might just be entry points to go to the elevator.
Okay.
Yeah. Or they could be, they could have, there are some plastics or water that you can use as insulation or as shielding that they could have put in the walls, but that really complicates your structure.
One of the things they could do is go looking for Matt Damon's refuge and
Yeah.
waste. Gentlemen, we've run out of time. Always fascinating to talk to you and learn stuff. And I'm proud to be part of this and proud of the fact that SBAU is back. We're not going to be live we're all going to be in the Parent Hall this coming first Friday of April. But we're going to have a gentleman from Toronto, the University of Toronto, speaking to us virtually from Canada. And after that, we'll go to LCO. In the meantime, thank you very much for a stimulating hour, guys. We'll do it again next week for number 108. Take care of
Okay.
yourselves, your wives, and your cats.